Yeah, we'll get started. Well, welcome to the Go Meetup, Go user group. We have, I think we're equal parts in person and remote on attendance at this point, which is nice. Will somebody go help the DoorDash guy figure out where to come with the drinks? Thank you, Carson. There were no drinks in the building, so I had to DoorDash them. Just some quick announcements. Feel free to join the Forge Slack at any point. We have a really great community there where you could talk about Go and Kubernetes and development and all the cool stuff that's happening in the world. And every once in a while, some people that work at Google will post about things happening at Google. And people that work at Microsoft will post about things happening at Microsoft.
And we tolerate their presence.
Yeah, and we're okay with that. I will put a link for that in the chat here in a couple minutes. We also have a job board there. If anybody is looking for a job or hiring, that's a great place to post those links. It's pretty active. We had a couple posts there this week. Other announcements, we will have a meetup next month. I just don't have a speaker. I am looking for speakers, so if anybody wants to speak at any point in the future, feel free to DM me. Sean's on my list to contact, so you don't have to DM me, Sean. I will reach out to you at some point because you're on my list. And there's also going to be a Go conference happening sometime in October, on the 22nd of October. It will be hybrid at the Go conference, and the speakers will be published on the website shortly. And if you have any questions about that, you can go to the Go West Conf Slack on Forge Slack, or you can ask me, or you can ask Derek. Derek's the other guy who's in charge. And yeah, that's all I have for announcements. Did I miss anything? No?
I don't think so.
Cool. The time's all yours, Grant. You can go ahead and share your screen, introduce yourself, and give your talk.
Great. Well, hello, everybody. I will get started with the presentation. There we go. All right. We're going to be talking about a calendar event system tonight that I've been working on for the last few months at Weave with other people who have also contributed greatly to this. These kind of the lessons learned and takeaways from this will be from mostly the back end perspective of building it out, and it'll focus in on just the events aspect of the system. There are some other calendar settings and other kind of key pieces for it to all work, but this was the part I was closest to. And this talk probably could have been titled like mistakes made while building a calendar event system too. But these are the learnings I've had from it so far. It's still kind of a work in progress. We're really just starting to use it with customers. And I'm sure there's going to be a lot more lessons learned along the way. If anybody has questions as we go through, or you've got feedback on how we can improve it or something else I missed with the learning, feel free to pipe in, because I would love to add to the list of lessons learned on this. So for those of you who are Parks and Rec fans, hope you're all as stoked as Andy is about this presentation. We're going to talk about the requirements, just kind of general things that we needed to accomplish during the project, what the end solution looked like, and then I'll go more into the nitty-gritty of like things I learned in regards to specific technologies along the way. And that should be it. So quick intro before we jump in. Weave, where I currently work, we've got a fun tech stack to work on, and it was actually at a meetup similar to this, probably a year and a half ago, where I first was really turned on to coming to work in at Weave. It was like the lightning talks round of this Go user group meetup, and over half the speakers were from Weave that night, and I was like, man, that's very impressive. We must have, some of the best talent in the Valley to have that many speakers at the event. And then after joining Weave, I learned that Weave is really good at incentivizing people to speak at conferences and things like this. So while you have some great talent and great people to interact with, We've also just getting people to speak at meetups and conferences. Outside of, so I work on the back end at Weave. I worked kind of in a data engineering context previously too at NAV. I've done a little bit of freelance work and spent a little bit of time at BYU as well, working. Outside of work, I really like mountain biking. I moved to St. George about 8 months ago. Been loving checking out all the trails and the outdoors down here. It's a warm time of year down south. I think it's warm everywhere, but if we were at about 113 degrees today, and you could feel it. It was hot. So anyway, a little bit about me and a little bit about Weave there. But let's jump into the actual project and learning this from it. So to start off, we really had just some basic requirements that we needed to improve what was then a really basic scheduling assistant that we provides to our customers' customers. So that, for example, if you're going to go to the dentist, rather than calling in to say, hey, I want to come in, when do you have openings? You just go onto their website. We've got a little widget where we say, hey, here's a time you could request an appointment, and people could book that appointment directly through that widget. Makes the process a lot faster. But as we were beta testing this with customers, one of the pieces of feedback we got was that they would really like to see a tighter integration with the kind of the data sources that they rely on, where they already have an existing calendar that already kind of shows what some of their openings are and what some things that are already reserved during certain times. So we needed to be able to calculate, like, hey, here's when the openings for the office really are, based on whether if it's in the dental vertical, it would be like the dentist and the room that they're going to work in, and maybe if there's tools or an X-ray machine or something associated with a specific event or calendar appointment, we would need to account for all that stuff before somebody could book the appointment online. So that's kind of like the use case we had to fulfill right away. And then in a broader sense, we just needed to be able to manage these calendar events in a kind of source agnostic way so that it could look the same and we could do the same calculations and the same logic on all of these things that lived on various types of calendars throughout our customers' data sources. We rely a lot on gRPC that as far as backend implementations go, and so we needed to have the RPCs to accommodate all of these things, and then a requirement that came up later is we wanted to be able to port any of this info that we had to an internal calendar that could also go external if somebody wanted to use our system more as a platform. So in that same vein, we needed calendar events just like you would have on like your Google Calendar that could repeat on some frequency, like every other Tuesday or once a year or whatever it is, and then also events that are just kind of one-off items. The quantity of records we were looking at for the database was probably around 2 million per week of these kind of core records that we were going to be storing. We need to keep them around for a couple of years. And then for us, the read time was the most important thing to our customers. It was okay if our process of getting the events written into the calendar took a little bit longer, as long as we could calculate those openings really quickly. So we needed to read optimize the database. What we ended up building, I think we'll kind of dive more into this, but we've got these front-end clients, we've got these producers of data sources that are kind of pushing these things to us that we're going to write into the service, the event service, and then some internal clients that might also consume this data from us or leverage it for other product features. So we set up our protobuf definitions. We set up our gRPC server to just kind of satisfy those service definitions. We used Go as that server, and then translating between the gRPC generated types over to sqlc, which is a cool library that I'll just kind of briefly intro for those of you who haven't heard of it. Those who have, had a positive experience with it too. and then that all just got written down into the database, which is Postgres. So we had somebody at Weave, Keith Branton, who loved to say like plans are nothing, but planning is everything. I think that quote comes from this, but I always think of Keith when I think of that because I heard him quote it the most. But during this process, we spent a lot of time going back and forth on what our proto definitions should be and what the what the database structure needed to look like. And honestly, we're still going through and revising it a little bit at a time as we learn more. But the process of getting really deep into those plans has given our team a better understanding of really what the problems are that we have to solve, and just given us all like a really deep understanding of how everything is working. So even if we ended up throwing away those plans really shortly, like do our first iteration, and by a few days later all that stuff was gone and we were working on the next iteration, it gave us a good like common foundation of knowing why the system was in the state that it was in. So here's the order of technologies I'll go through as far as the learnings. So we'll talk about a few things from gRPC and then go sqlc and Postgres. With gRPC, my first thing that I learned, and this is kind of thanks to our DevX team, I had led our team in the wrong direction, assuming that all of our proto definitions should just be based on the Google API style guide. That's what I had always used, building proto definitions. And so we started doing some of that, and all of a sudden our definitions weren't quite lining up with the way that our linter was set up. And so I started asking around and found out there's actually 4 main style guides. The one we follow at Weave now is the Buff style guide. But the Google Design Guide and the Google API Style Guide are actually separate, two different style guides that Google's put out in different use cases. And then there's the Uber Style Guide that came along a little bit later. And then Buff takes a lot of what the Google Design Guide and Google API Style Guide had with the Uber stuff on top of it. And then they also added some other own stuff that allows you to leverage Buff's strengths better. If anybody has comments too, sorry, I'm going to be going too fast, but feel free to interrupt still. Over here on the right, I just put a code sample of an enum from each style guide just to kind of point out some of the key differences. So like the Google style guide, you would always prefix your enum with the enum name, which is foo in this case, foo underscore whatever for each value in there, and you're allowed to alias things. And then you jump over to the Uber style guide, you're still prefixing with foo on every possible value of the enum, but you're no longer allowed to alias. So you couldn't have 2 different named things in the enum pointing to the same number. Whoops, sorry, scrolled. And then it goes. You could keep going through the Google API design does allow the aliases again, but then you're prefixing the enum values a little bit different, and so on and so on. I think what we're using right now as far as the linter goes at Weave is the default, which is pretty strict and great. I love having all of that assurance that if I pass the Buff linter, things are probably not going to break because it's pretty strict about breaking changes and following naming conventions and everything. But you can set your own level of if you want basic or minimal, and then strict is one that they haven't released yet, but apparently that is supposed to be coming soon. So there's one quick learning from gRPC and protobuf. This one maybe isn't specific to gRPC so much, but we spend a lot of time in the design phase on our proto definitions, and this little diagram comes from the Martin Fowler blog on architecture. It just points out that you invest more initially when you're trying to build something for the future. When you're trying to build something that's going to last, it's going to be good quality, and it feels like a big slowdown. We've got to tell stakeholders, hey, this is going to it's going to take a month to get this thing in place. When really you could implement something hacky in a couple of weeks, but then you'd have to rewrite it really soon. And so the point made in this diagram and talked about more on the blog is just that you actually get the payoff sooner than you expect when you put more time in up front to build quality systems and take the time to plan, take the time to clearly define, check in with all your stakeholders, make sure everybody's on the same page before you move forward, and you get that payoff. And the point here is you get it in weeks, not in months. And then you get to keep reaping the benefits of that over time, so you don't have to keep redesigning and redesigning. And it did feel initially when we were redesigning our proto definitions over and over in a short amount of time, it almost became a running joke of like, all right, back to the proto definition, because we discovered something new and we were changing it all up again. But hopefully we're going to see the payoff of that. So jumping over to Go now, and just kind of some of the learnings as I was working in Go to do the translation between our gRPC layer and down into sqlc. Okay, the first learning was take time to understand your problem space. So you've got this image here of somebody with a brand new idea. They've got a wheel and they're just reinventing it, obviously. And it's not cool to reinvent the wheel. It takes a lot of time. And if you end up with a wheel that's not compatible with other people's wheels, you're in trouble. So I think where we may have gone wrong initially is that we came in with some prior assumptions and like a little bit of legacy code already that we were working with, to where we were just trying to satisfy our one use case of calculating openings for the thing that we needed. And as we started breaking down that problem more and more, the more we realized, oh, we actually really need just a general calendar events system. And that's pretty common. Like a lot of people have already built APIs around that and already set up specs like iCal for transferring calendar events between systems. So then it was just a matter of taking some of those learnings, applying them to our use cases, accounting for maybe some of the key differences, but still supporting the more general, objects and more general specifications that were widely accepted. Another learning in Go is I've often seen where you've got, like if you've got tests built into your pipeline, you'll have tests that are like passing intermittently, where you have some inconsistent ordering in the results of your tests. And so like sometimes stuff will get merged into your main branch, and your CI/CD pipeline will be failing on that main branch when you go to merge in your next thing that like doesn't touch anything else, because somewhere in the tests, like there's not a guarantee of order, and so you end up with broken tests or whatever. You have to go track it down and figure out where things are going wrong. So initially I wrote this test and it had all these assertions because I was working with some structs. It was like a slice of structs that had other slices inside of it, and those slices got built by some maps that were used for uniqueness. And it was just so messy and complicated when I was running all my assertions on the final output, just to make sure that, hey, I was checking that everything was the right way without having that potential failure of like tests inconsistently passing. And it was messy enough that I said, something looks wrong. And I ran it by Michael Whitcott, who we're lucky enough to have at Lead now, that helps start and run, I think still runs the Go Convey library and some of the other stuff that was put out in Smarty Streets. And he said, oh yeah, why don't you just sort your slices first, and then you can just still do your single, like should resemble assertion to make sure everything is good to go. And it was a really simple thing, but it ended up saving me all these extra assertions. And I realized, like, oh yeah, even if I've got somewhere in my code that is not guarantee order, like I've got a map that's being used for uniqueness that ends up getting translated to a slice, as long as I sort that again, I'm good. So there's one learning. Just watch out for that in your tests, and hopefully sort your tests or sort your slices when you're testing so that you get consistent output. And then the last thing was just something I haven't taken time to go over in the past, and that's different versions of UUIDs. I often will work with like, V4s or maybe V5s, and you're just using them everywhere in the system, and so you don't think about like, what's the purpose of a V4 versus a V5 versus a V1? Why would you use which one? So I finally took the time to go through them, and hopefully I can save somebody a little bit of time if you haven't reviewed them recently. So the three main ones that are used are the V1, the V4, and the V5. The V1 is usually generated based on your MAC address and the time, some timestamp associated with when the ID was generated. I think there's a little bit of randomness tucked in there as well. That one, I think there's like a few privacy concerns, and maybe you don't always want people to be able to figure out the IDs or figure out your MAC address based on IDs, or be able to tie that back. The V4 is great if you just need random. You don't need a deterministic UUID. You just need something that's not going to collide, and it can mean whatever. It doesn't have to be reproducible as far as consistency goes. And those, as far as collisions, you have to do trillions of them every second for years before you end up with a collision. So they're really good with just random IDs. The V5 is deterministic. It takes an input string and a namespace. And given that same input string and namespace, it's always going to give you the same output. It's almost the exact same thing as the V3, except that the V3 is using the MD5 hash instead of the SHA-1 hash to come up with the result. So because SHA-1 is better, stronger than MD5, the V5s are recommended to use those over the V3s. And then the V2s are kind of funny. You can use V2s as long as you're okay with only having an ID once every 7 minutes or longer. So if you need collisions, I guess, then V2s are the ID for you, but probably not the usual UUID to use. All right, so going down to the next layer in the stack, we use a library called sqlc. We've used this on a few projects. Kyle Conroy, I think, is the name of the maintainer on this one, and I think he's done a really good job with it. So the way sqlc works is, rather than kind of setting up like your Go structs and then having those get converted into some database representation, you're actually going the other way, and you are setting up your database schema and then writing the queries that you're going to use on that schema. And then it generates the Go for you as far as like the structs that it's going to marshal into, and all like the query methods to call, which is just great. It takes out some of the user error. It saves you a bunch of time of having to write code. Because at least from my perspective, you want to be able to optimize your queries. If you have performance concerns or something else, it's really nice to have a really specific query to the way you need things to work, as opposed to the other way around, where you're like trying to generate maybe SQL based on Go, or if you're just going to type it all by hand, it just takes a lot longer. So pretty cool library. I haven't seen a lot of downsides to it so far. The one thing I've noticed is it doesn't do well with bulk inserts. So if you're trying to put in a bunch of records at once, you either need to start up a transaction and do a bunch of individual insert statements, or you need to like write an insert statement for every possible number of records to be inserted at once, which would be messy. So there's not a great solution to that yet that I know of. Maybe somebody else does, but that's kind of been my experience with sqlc so far, and it's been like so much as far as time savings goes. You can just kind of specify your own custom types even. So it does that conversion for you of like, if you've got a specific like special UUID type you use in your gRPC request, and you want that to get translated to Postgres UUID type without having to write your own conversion logic along the way, you just tell sqlc, hey, overwrite this specific column of this specific table with this UUID type, and it's still going to convert that to the schema type of UUID that Postgres supports. But when it comes out in Go, it's going to be your own custom UUID type. So it saves a lot of time. I'm a big fan of that library. All right, getting into the Postgres layer. So down in our database, we use Postgres quite a bit at Weave, so it was a good option for this service just because it's widely supported, and our data pretty much made sense in a relational model. So two things that I kind of came across or learned a little bit about as we were working on this was just how to optimize our performance for these use cases, and then the array aggregate function. The first thing with optimization, we looked at 4 main options. Here on the left, you can see what our database schema, at least a piece of it, looked like, where we had kind of these main core tables, then we had these many-to-many relationships, these linking tables that actually tied out to data in other source systems. And as far as going back to the read optimization that we had as a requirement at the beginning, we needed to make sure that when we had 100 million events records in these tables, that we would be able to efficiently pull all the openings, calculate those, and also handle our other use cases of just creating, reading, updating, and deleting calendar events. So we started off just thinking, what if we just do our normal indexes? And the one downside to that is, as your table gets bigger and bigger, I mean, maybe there's other downsides, and I'm definitely not a Postgres expert. So if anybody has more to add on this, I would love to learn. But you can get indexes that are going to exceed however much memory you have allocated to the box when your table gets really big. So if you're picturing like a map for everything in your table, that, if that map was to get excessively large, your queries would start slowing down because it's got to load that whole map up, and if it exceeds memory and it's got to write to disk or whatever, you get some read and write access issues. And we had run into an issue with this not too long ago with a slightly different context of product within Weave, but we started having to slow down when we got to so many million rows that we were reading and writing to. So we looked at what else could we do to speed this up so that we don't get boxed in down the road. So the next option was partitioning by the start time of the event, because primarily when we're accessing these tables, we would be querying based on what time something was happening. It might be like, what's coming up in the next week or in the next month, or what happened last week, but it typically revolved around time. And so we thought, if we can consolidate the number of sections of the table that we even have to look at for any given query, we'll get some increased performance, and then that reduces the index size. So you're not, because your indexes are now specific to each partition, you're not at risk of having an index that exceeds the memory available. And the one downside to that is just managing the partitions is a little bit more work. So another thing we looked at was you can set up partial indexes within Postgres. So if you want to index on like whatever the primary key is of the table, you don't actually have to index on the whole column. You could say, I want to set up an index on this key, but only for the rows where this condition is satisfied, like this start date column is between these dates, and build a partial index that way. So kind of a cool thing, I didn't know that you could do indexes that were only on part of the table, but there weren't some of the advantages that we got with the partitioning in that case, like just some of the data cleanup stuff, that if we wanted to like archive a big chunk of data or something else, if we already had it partitioned, it was easier to do than just dealing with these partial indexes, where we've got to keep updating the index, but do data removal process. And then the fourth option looked at was time series. It's a really cool extension that works right in Postgres, and it will manage those partitions for you. A few people within Weave, Casey and Jared and some others, kind of pointed me towards this. Really cool as far as like, if you set up your partitions by these start times, and then you don't have to like keep thinking about them and keep updating the date range on those partitions or whatever. With time series, you can pretty much just say, hey, give me like a few 2-week partitions that, like, this one's 2 weeks from today, and this one's whatever, and it'll just kind of keep running that for you, so you don't have to manage your partitions as much. We didn't end up going with it because GCP doesn't support yet Google Cloud Provider, which we use for our databases right now. And anyway, we just didn't have the support for it quite yet. We didn't want to be on the bleeding edge. So we ended up going with just the partition and biaxial start time. And that's, partitions aren't always going to be the answer. I think every use case is going to be a little different. But that was just some of the kind of learning process that we went through as we were trying to figure out for our use cases, for our queries, how can we best optimize towards these database reads. Okay, and then this one more learning from Postgres is just a function I hadn't really used before, and it's an aggregation function, just like a sum or a max or a min or a count even. But this is the array ag or array aggregation, maybe array aggregator function, and that'll take. You can see on the left here is kind of like the initial example query. If you've got an event ID, a user ID, location, a source ID, and if you're left joining these tables, you've got the initial ID repeated over and over and over and over, which isn't that big of a deal, except when you then go put that into your Go structs, you've got to do some logic to consolidate that back down to like what you're actually going to send over the wire, which can just make for some messy code that's extra, it's complicated. And it's one more spot that things could fail that they shouldn't have to. So using this array aggregate function in that query, instead, you can just say, hey, give me basically a JSON array back of all the things that are potentially like this many relationship back to my event and group them all in the same row. So now we have one row per primary key that we're looking at, this event ID, and translating that into our gRPC layers, especially with sqlc, was super simple because now like our array of strings, our JSON array coming out of the database can just be directly into this array of strings or array of UUIDs that gets sent back over the wire without us having to do any extra work or any extra processing inside that server. So something simple, something probably a lot of people already know about. There might even be, I don't see a lot of drawbacks to doing it this way. Maybe there are some. I haven't learned them yet, but just a cool way to kind of simplify some of your code and help the translation, like the data structures being returned, more accurately reflect kind of your end product. So just a summary, things we've talked about. With gRPC, pick your style guide, know which one you're working out of, so that it can be consistent across teams. Invest in design up front; it pays off quickly. With Go, don't reinvent the wheel. Understand your problem space. See what other APIs are out there that might be really similar to what you're trying to build. See what general RFCs and specifications are out there that might make communications easier. When it comes to testing, sort your slices, make sure that you've got consistently passing tests. And then just remember what those different UUID types are. The V4s being the random ones, the V5s being deterministic. sqlc, it's pretty cool. I think everybody should use it, but it's just my opinion. And Postgres, use your partitions and indexes, and then aggregate your arrays before you return them. That's it. Those were the lessons I learned. Does anybody have questions or comments or anything else you wanted to discuss on this?
Hey, yeah. My name is Jacob. I'm just calling in from Riverton. I have a quick question about sqlc. How does it handle like scaling or changing data sets? Like if you need to change your queries, is that pretty easy to use to update your structs and things?
Yeah, so my experience so far, I'll pull up the library too, has been that it is really easy. So it supports kind of all your main migration libraries. So if you're like using Goose or Pomegranate, I don't even remember what all the other alternatives are out there. But whatever you're using to manage your schema migrations, sqlc will likely support it. And then as far as changing your queries goes, you'll update a little bit of code, but as long as like the end response is the same or the same types are the same, yeah, it's been pretty flexible from what I've seen. Like because you don't have a whole lot of code, in between, like whatever your REST or gRPC or communication layer is in the database layer, it doesn't, like, it makes for very little that has to change in between, even if there's something that's got to change.
Yeah. Oh, that's cool. This is the first time I've heard of that, and it looks awesome. I'm going to try it out this week. Thanks.
Good. Yeah. Glad to hear somebody else can benefit from it.
I had a question. During your sample tests, you did a lot of non-Go-ish style assertions. What package are you using for that?
Yeah. And I should have noted too that those are, let me scroll back up to there, that those tests are actually all wiped out now. The code is a lot cleaner due to some of the array aggregation and some of the sqlc stuff. So anyway, the library that I was using in there was GoConvey, has an assertions library it depends on, which is like Smarty Street's assertions. And it's got just some helpful stuff. Like the should resemble, I'm pretty sure is going to do mostly the same things as like a deep equal, except if you're testing a deep equal and you have like a nil struct in your result versus what you wanted was like an empty struct or something like that. A lot of times should or deep equals like won't show you that difference, so you're like frustrated, like what it says like what I want and what I got are the exact same thing, but they don't match. Like why is that? And the should resembles is really good at like calling out the differences. So be like, oh, here you got this open quotes curly brace indicating this empty thing versus like the nil version of it and what you actually got.
So it isn't more permissive, because resemble seems way more permissive to me than should equal.
Yeah, I actually, somebody else might know. Maybe it is more permissive. From what I've seen, it's very similar.
Okay, no, that's fine.
But there's also this assert.elements match. That one comes from the testify assertions library, and that one is for arrays where things are out of order, or sorry, not arrays, slices. So you can support out of order slices comparison and still have it say that they're equal.
Sure. All right. Yeah, I was just curious.
Yeah, I like GoConvey is really nice if you've got big messy tests and you need to view the results diffed really cleanly. But hopefully your tests aren't big and messy like mine are, and so you don't have to view the results diffed like that.
Yeah, I'm personally generally against using assertion libraries in my Go tests, but that's because I'm a purist. So, I mean, there's cases for them. There's cases for I've had to use Go Mega and Kink Go recently, which both have similar kind of functionality, but deep equals is basically useless with the diffs. I can't use there's a deep package that is for testing that has an equal that returns a slice of string like descriptions of the diffs instead of just like this giant blob is not equal to this giant blob.
Yeah.
So I'm with you on like the normal deep equal is not useful for actually debugging the problem.
Yeah, you said that was Ginkgo?
Gink Go, yeah, and Omega builds on that. So.
Cool.
But
yeah, more power to you if you can do it just with all native Go assertions.